Hello everyone, welcome to this session. In this session, I am going to discuss the thermodynamic properties, which is a part of the basic thermodynamics basics, and it is a lecture 3. In this session, I am going to discuss the types of the thermodynamic properties like intensive and extensive properties. Some other properties under these, like their definitions and units, I am going to discuss. Those properties like pressure, density, specific value, temperature, and specific properties I am going to take. Then, what are the thermodynamic properties? We'll take first the variables which determine the state or a exact condition of a substance or a system is called as its properties. The various properties of thermodynamic system are pressure, temperature, specific volume, internal energy, enthalpy, entropy, etc. Internal energy, enthalpy and entropy I am going to take in the further sessions after the first law of the thermodynamics because those will comes later. And remaining property I am going to take here. Basic property I am going to take. Thermodynamic properties are classified as intensive and extensive properties. Those are intensive and extensive properties. First, we will take the intensive properties. The intensive property means the properties which are not depend on the mass of the system. The mass of the system, what is there, on that these properties are not depend. It is the property of the system whose value for the entire system is not equal to the sum of their values for individual parts of the system. Here, the summation of the each part of the property, if you take, that will be not equal to the total sum of the system. That is not true for this intensive properties. Example we will take density of water is constant, that is a 1000 kg per meter cube, and the value does not depend on the mass. It may be for the particular the 1 liter volume also the density will be remain same, and 10 liter also it will be remain same. It does not depend on the mass. For 1 kg also density same and 10 kg also same. The other intensive properties are temperature, pressure, density, heat and work. These are not depend on the mass. Extensive properties, these properties which are depend on the mass of the system. These properties depend on the mass of the system. The properties of the system whose value for the entire system, is equal to the sum of their values for the individual parts of the system. If we divide the system itself into the number of parts, then the whole value will be equal to the sum of each part properties. And such properties are the extensive properties, are called extensive properties. Example here kinetic energy, potential energy, internal energy, and total volume, total mass, enthalpy, etc. Okay, these are the extensive properties. Now, the few basic property out of these we are going to discuss. And that first one is the pressure. Pressure may be defined as the normal force per unit area. It is denoted by P and its SI unit is Pascal. Okay, it is a force per area. F by A is the pressure and it is denoted as a P and its unit is Pascal. That is Newton per meter square. Also, here I am going to take the units of the pressure. 1 Pascal is equal to 1 Newton per meter square. 1 kilopascal is equal to 1000 Pascal. 1 megapascal is equal to 10 raised to 6 Pascal. That is a 1000 kilopascal. One standard atmospheric pressure. The standard atmospheric pressure, what we call, that is 1.01325 bar or 101.325 kilopascal. That is equal to 101.101.325 Pascal, or that in terms of the mercury head, if you measure 760 mm of Hg, then 1 mm of Hg is equal to 0.1333 kilopascal or 13.6 millimeter of H2O. This is in terms of the H2O. If we express, we are going to take as a 13.6 mm of H2O. 1 bar is equal to 10 raised to 5 Pascal, that's 100 kilopascal. 1 Newton per millimeter square is equal to 10 raised to 6 Newton per meter square, 10 raised to 6 Pascal, or 1000 kilopascal. The next property is that density. Density of a substance is defined as the mass per unit volume. Mass per unit volume. It is denoted by the rho and its SI unit is kg per meter cube. The next property is that volume. The space occupied by the substance is called volume. It is denoted by meter cube. 1 liter is equal to 1000 cc or 10 raised to minus 3 meter cube. This is the volume, the total volume occupied by the particular system. Specific volume. The specific volume we are going to take as a thermodynamic property. It is specific volume is the volume per unit mass of substance. Volume per unit mass of the substance or volume occupied by the substance. Unit mass of the substance is called as a specific volume also. It is denoted by second letter V and its SI unit is meter cube per kg. It is the reverse of the density of the substance. The reverse density is mass per volume and specific volume is volume per mass. Temperature, it is a thermodynamic property which measure of degree of hotness or coldness. How much hot or how much cold it is there, that is measured in terms of the temperature. That is a level of heat intensity of a body. How much heat intensity is present in the body, that can be measured. Its unit is degree Celsius or degree Kelvin or degree Fahrenheit. Any one unit we can use. Degree Celsius or degree Fahrenheit usually used and degree Kelvin is used for the absolute temperature measurement. Specific properties, extensive properties per unit mass are called as a specific property. Example, specific volume, specific enthalpy, specific energy. These are the specific properties. Whatever the specific per unit mass, whatever we are going to take in the thermodynamics, those are the specific properties. The some other properties like internal energy, enthalpy, entropy, all those I am going to discuss in the further sessions. These are the only basic properties of the thermodynamics. Thanks for watching. If you like, share, subscribe, and comment.